We often speak as though the mind were a thing one might point to, a location one could circle on a diagram of the brain. Yet this habit conceals a deeper confusion. The mind is not a lump of tissue nor a flicker of electrical activity alone. It is a structured process whose reality seems to outrun the material scaffolding that supports it. When we ask where the mind is, we are really asking how meaning, understanding, and insight come to inhabit the physical world at all. Physics has taught us, sometimes against our intuitions, that the world is not stitched together from solid certainties. Instead, it is woven from mathematical relationships of extraordinary subtlety. In that sense, our minds appear to participate in something curiously non-local. A mathematical truth grasped today is the same truth grasped centuries ago. It does not age, erode, or wander through space. When you understand a theorem, nothing travels from the page into your skull. Rather, your mental state aligns with a timeless structure that seems to exist independently of both ink and neurons. This alignment is the real mystery. Neural activity is undeniably necessary for thought, yet necessity is not identity. One may know everything about the vibrations of a violin string and still miss the music. The mind, like the music, is not found by dissecting its instrument. It emerges from the organization, the coherence, and perhaps from principles we have not yet learned to articulate in purely computational terms. Some of the most unsettling insights of modern physics hint that reality itself resists being reduced to a simple algorithm. Quantum theory, for all its predictive power, leaves us with a world that is not merely uncertain but fundamentally contextual. What is observed depends, in a deep sense, on how it is observed. This raises an uncomfortable possibility. Consciousness may not be a passive spectator, but an active participant in the structure of reality. Not in a mystical way, but in a precise, if still obscure, physical sense. If this is so, then the mind is not neatly boxed inside the head. It is anchored there, certainly, but it also reaches outward into the mathematical and physical order of the universe. Understanding becomes a bridge between the biological and the abstract, between firing neurons and eternal forms. The shock lies in realizing that cognition is less like data processing and more like discovery, as though the mind were tuning itself to patterns that already exist. Thus, when we ask where the mind really is, the honest answer may be that it occupies several domains at once: the physical, the mental, and the mathematical. To locate it in only one is to miss its essence. The mind is where structure becomes meaning, where the universe, however briefly, comes to know itself. When we ask where the mind is, the question seems straightforward, almost anatomical. We instinctively gesture toward the head, toward the brain, as though the matter were settled by proximity. Yet this confidence dissolves under closer scrutiny. The brain is unquestionably essential for mental life. But to say the mind is simply located there is to confuse correlation with identity. The mind does not sit inside the skull in the way an organ sits inside a cavity. Rather, it unfolds as a pattern, a dynamic process that cannot be cleanly mapped onto any single region of space. Consider what it means to have a thought. A thought is not a physical object with clear boundaries. It has no mass, no precise coordinates, and no fixed duration. It can refer to distant galaxies, ancient civilizations, or abstract mathematical entities that have no physical location at all. When you think of a triangle, there is no triangle hidden in your neurons, only electrochemical activity that somehow corresponds to the concept. The triangle itself, with its perfect angles and relationships, exists nowhere in space, yet it is undeniably real to the mind. This alone suggests that mental content transcends the physical substrate that supports it. Neuroscience can tell us which areas of the brain are active during certain experiences, but activity is not meaning. A scan may show patterns of blood flow or electrical firing, yet it does not reveal the experience of understanding, the sudden clarity of insight, or the felt quality of awareness. These subjective aspects are not spatial features. They cannot be located in the way one locates a tumor or a synapse. They arise from organization and coherence, not from position. The mind, in this sense, is less like a place and more like an event. Language quietly reinforces this confusion. We speak of holding ideas, grasping concepts, or losing a train of thought. borrowing metaphors from the physical world to describe something fundamentally non-physical. These metaphors are useful, but they mislead us into thinking the mind must occupy space in the same way objects do. In reality, mental states are defined by relationships between ideas, memories, perceptions, not by where they sit. A memory from childhood is not stored like a file in a cabinet. It is reconstructed, reactivated, and reshaped each time it is recalled. There is also the curious fact that minds can extend beyond individual brains. When you read a sentence and understand its meaning, that meaning is not confined to the page or to your head. It exists in the interaction between symbols, shared language, and your interpretive capacity. Two people can grasp the same idea simultaneously, even though their brains are distinct and separated in space. This shared understanding cannot be pinned to a single location. It is distributed across systems, conventions, and cognitive acts. Even tools complicate the picture. A notebook, a calculator, or a musical instrument can become part of one's thinking process. When a pianist plays, the music is not solely in the fingers, the keys, or the mind, but in the coordinated system that includes all of them. Similarly, reasoning can spill outward into diagrams, equations, and external representations. The mind, then, is not sealed off inside the body, but reaches into the world, recruiting structures beyond the brain to complete its work. To insist on a single location for the mind is to impose a spatial framework on something that operates according to different principles. The mind is not nowhere, but neither is it neatly somewhere. It is instantiated in the brain, expressed through the body, extended into the environment, and oriented toward abstract realities that exist beyond space and time. Asking where the mind is may be the wrong question altogether. A better question might be how the mind comes to be, and how something so deeply physical can give rise to experiences that seem to transcend location entirely. It is tempting to believe that once we have mapped every neuron and recorded every electrical impulse, understanding itself will lie exposed before us. The brain, after all, is an astonishingly complex machine, and its activity correlates reliably with thought, perception, and memory. Yet correlation is not the same as equivalence. To mistake neural activity for understanding is to confuse the physical description of a process with the meaning that process somehow brings into being. Neural signals are measurable events. They have timing, intensity, and location. Understanding, by contrast, has none of these properties in any straightforward sense. When someone suddenly understands a difficult idea, nothing about that understanding tells us where it is, how heavy it is, or how fast it moves. What changes is not merely the brain's activity, but the relation between ideas, the coherence of a conceptual structure. One can describe every chemical interaction in the brain at that moment, and still fail to capture what it means to understand why something is true. This distinction becomes clearer if we consider that the same understanding can be realized in very different physical systems. Two people can grasp the same mathematical insight even though their brains differ in structure, history, and moment-to-moment activity. The neural patterns will not be identical, yet the understanding is recognizably the same. This suggests that understanding is defined not by the specific physical details of its implementation, but by a higher-level organization that can be instantiated in multiple ways. The brain enables this organization, but it does not exhaust it. There is also a crucial difference between processing information and knowing what that information means. A computer can manipulate symbols according to rules with extraordinary speed and precision. It can produce outputs that look indistinguishable from those of a human reasoner. Yet the machine does not know what it is doing. The symbols mean nothing to it. Understanding involves insight, relevance, and context, none of which are captured by syntax alone. Neural activity, like computation, may be necessary for understanding, but necessity does not imply sufficiency. Meaning itself is the stumbling block. Neurons fire, chemicals diffuse, electrical potentials rise and fall. Nowhere in this physical description does meaning appear, and yet meaning is central to understanding. To understand a sentence is not merely to register its sounds or letters, but to apprehend what it is about. This aboutness is not a physical property. It is relational and intentional, pointing beyond the brain to the world, to abstract structures or to other minds. Neural activity can support this pointing, but it is not identical to it. Consider a simple example: recognizing a face. The visual system processes shapes, contrasts, and movements, all of which can be traced through neural pathways. But recognizing the face as belonging to a particular person involves memory, significance, and emotional association. The same pattern of pixels can be meaningless noise to one observer and deeply familiar to another. The difference is not found in the pixels, nor solely in the raw neural activity, but in the structured understanding that connects perception to identity and meaning. If understanding were nothing more than neural firing, then increasing the amount of activity should increase understanding. But this is plainly false. One can be overwhelmed with sensory input and understand nothing, or grasp a profound idea in a quiet moment with minimal stimulation. Understanding is selective and structured. It depends on the right organization, not the sheer quantity of physical events. None of this diminishes the importance of neuroscience. On the contrary, it highlights its limits. The brain is the enabling condition for understanding, just as ink and paper enable a written proof. But the proof is not reducible to ink, and understanding is not reducible to neurons. To conflate them is to miss what is most distinctive about the mind, its capacity to generate meaning, insight, and truth from processes that, on their own, contain none of these things. There is a peculiar feature of human consciousness that resists any attempt to anchor it solely in the flow of time and matter. When the mind understands an abstract truth, it seems to make contact with something that does not change, something that was true long before any individual became aware of it and will remain true long after. A mathematical relationship, a logical principle, or even a deep conceptual insight does not age. It does not decay, drift, or evolve in the way physical systems do. Yet consciousness can apprehend it directly, as if tuning into a signal that has always been present. This raises an unsettling question. If abstract structures are timeless, and if understanding them is a genuine form of contact rather than invention, then consciousness appears to reach beyond the immediate physical moment. When one understands that the angles of a triangle sum to a fixed relation, nothing new has been created in the universe. The understanding is new to the individual, but the structure itself is not. It existed before any brain represented it, and does not depend on any particular brain for its validity. Consciousness, in this sense, seems less like a generator of truths and more like a detector. What makes this especially striking is that abstract structures are not located anywhere. They have no position in space, no duration in time, and no material substance. Yet they exert a powerful influence on physical reality. The equations governing motion, energy, and symmetry shape the behavior of the universe with astonishing precision. When the human mind grasps these structures, it is not merely manipulating symbols, but recognizing necessity. One does not decide that a theorem is true. One sees that it must be so. This sense of inevitability is not imposed by neurons, but discovered through them. Neural activity, by its nature, is transient. Signals fire and fade, synapses strengthen and weaken, cells age and die. How then can such fleeting processes give rise to awareness of something eternal? The contrast is stark. The physical brain is immersed in time, while the objects of understanding often stand outside it. Consciousness appears to form a bridge between these domains, translating transient activity into stable insight. This bridging role is difficult to reconcile with the idea that consciousness is nothing more than computation or signal processing. Even more puzzling is the precision with which consciousness can align itself with abstract structures. When a proof is understood correctly, it is understood in exactly the same way by anyone who truly grasps it. There is no private version of the truth. Understanding is personal, but the structure understood is not. This shared access suggests that consciousness is not inventing meaning arbitrarily, but responding to something objective. The mind, in moments of clarity, seems to resonate with patterns that exist independently of it. This resonance hints at a deeper relationship between mind and reality. Abstract structures are not passive curiosities. They are deeply woven into the fabric of the physical world. The universe behaves as though it is guided by mathematical necessity. Consciousness, remarkably, is capable of recognizing that necessity. This alignment between the inner world of thought and the outer world of law is not easily explained by evolutionary convenience alone. Survival may favor useful beliefs, but it does not obviously require access to deep, timeless truths. One might object that abstract structures are merely human conventions, but this view collapses under scrutiny. Mathematical truths do not bend to preference or culture. They surprise us, resist us, and sometimes overturn our intuitions. Consciousness encounters them as something external, even authoritative. The feeling of discovery is genuine because there is something to be discovered. If consciousness can engage with abstract, timeless structures, then it cannot be fully described as a closed physical system. It is rooted in biology, certainly, but its reach extends beyond it. The mind does not float free of matter, yet neither is it confined to the immediate mechanics of the brain. It is a meeting point where time-bound processes gain access to timeless order, and where the universe, through consciousness, becomes aware of the deeper patterns that govern it. Modern physics has quietly dismantled the comforting idea that reality is simply out there, complete and independent of how it is examined. At the deepest levels, we know how to probe. The behavior of physical systems cannot be separated from the conditions under which they are observed. What is revealed depends not only on what exists, but on how the question is asked. This is not a matter of human ignorance or imperfect instruments. It is woven into the structure of nature itself. The act of observation is not a neutral glance, but an intervention that helps define what becomes real. This realization unsettles a long-standing assumption that the universe has a single, fully determined description waiting to be uncovered. Instead, reality appears to be contextual. Certain properties do not have definite values until a particular observational framework is imposed. Change the framework, and the outcome changes with it. This does not mean reality is arbitrary, but it does mean it is relational. What exists, in a meaningful sense, is tied to the interaction between system and observer. The implications for consciousness are difficult to ignore. Observation is not merely a physical process like collision or pressure. It is bound up with information, distinction, and awareness. To observe is to draw a line between alternatives, to register one outcome rather than another. Even if the physical mechanisms of measurement can be described mathematically, the notion of what happened only makes sense relative to an observer for whom something has happened. Reality at this level is not just about events, but about events becoming definite for someone or something. This does not require invoking human consciousness as a magical force that collapses the universe into shape. Rather, it suggests that the role of observation is more subtle and more fundamental. The universe is not a static collection of properties, but a network of potentialities that become actualized in specific contexts. Conscious systems are exceptionally good at creating such contexts because they discriminate, remember, and interpret. They do not merely register reality, they participate in its articulation. There is a temptation to retreat from this conclusion by insisting that observation can be reduced to purely physical interactions. Yet this move sidesteps the central issue. Physical interaction alone does not explain why one outcome is experienced rather than another, or why information takes on meaning. A measuring device may register a result, but it does not know that it has done so. The difference between raw interaction and observation lies precisely in this distinction. Observation is interaction plus significance. Context dependence also challenges the idea of a single absolute description of the world. Different observational setups can yield different mutually incompatible accounts, each internally consistent and experimentally valid. There is no privileged view from nowhere that gathers them all into a single picture. Instead, reality must be understood as a collection of perspectives governed by strict rules about how they relate. Objectivity, paradoxically, emerges not from eliminating observers, but from understanding how observations constrain one another. Consciousness fits naturally into this picture as a system that navigates contexts. It selects what is relevant, filters possibilities, and constructs coherent narratives from partial information. The world that appears to us is not the world in its totality, but the world as structured by our modes of observation. This does not make it an illusion. It makes it a collaboration between what is there and how it is encountered. If reality depends on context, then the mind is not merely a spectator watching a finished performance. It is part of the stage machinery that allows the performance to take shape at all. The shock is not that reality is subjective, but that it is participatory, a structured interplay between potentiality and observation, where knowing and being are more deeply entangled than common sense would ever suggest. We are accustomed to thinking of cognition as a kind of internal machinery, a system that takes inputs, applies rules, and produces outputs. This picture is comforting because it suggests that thinking is essentially a form of computation, differing from machines only in complexity. Yet moments of genuine insight do not feel like the execution of a procedure. They feel like discovery. Something that was previously hidden suddenly becomes clear, not because we followed a set of steps to their conclusion, but because a structure revealed itself as a whole. Consider how understanding often arrives. One may struggle with a problem for hours, applying known techniques without success, only to have the solution appear unexpectedly, fully formed, in a moment of clarity. The insight seems disproportionate to the prior effort. It is not assembled piece by piece, it is recognized. This phenomenology is difficult to reconcile with the idea that cognition is merely rule-based processing. Computation proceeds incrementally. Discovery, by contrast, has the character of revelation. This difference matters because computation is blind to meaning. An algorithm manipulates symbols according to formal rules, without any grasp of what those symbols represent. If cognition were purely computational, understanding would be indistinguishable from symbol shuffling. Yet understanding is precisely the opposite of blind manipulation. To understand is to see why something must be the case, to apprehend necessity, coherence, and relevance. These are not properties of algorithms, they are properties of structures that are grasped by a mind. Discovery also implies that what is discovered exists independently of the act of discovering. When a scientist uncovers a new law, or a mathematician proves a new theorem, the sense is not that something arbitrary has been invented, but that something real has been found. The discovery may be historically contingent, but its truth is not. Once seen, it cannot be unseen, and it does not depend on who sees it. Cognition, in these moments, aligns itself with something objective, rather than constructing something subjective. If thinking were merely computation, then novelty would be limited to recombinations of existent elements. But genuine insight often introduces concepts that feel qualitatively new. These concepts reorganize entire fields of thought, revealing connections that were previously invisible. Such reorganization is not easily described as the output of a fixed program. It looks more like a reconfiguration of perspective, a shift that allows an underlying pattern to come into focus. There is also an element of constraint in discovery that computation lacks. One cannot simply decide that a difficult problem has a particular solution and make it so. The structure either permits the insight or it does not. Discovery is guided by an external order that resists our wishes. This resistance is crucial. It is what distinguishes understanding from imagination. In discovery, the mind submits to the structure it encounters, rather than imposing its own. This submission suggests that cognition is, at least in part, receptive. The mind is not only an engine, but an instrument, tuned to detect patterns that exist independently of it. Computation emphasizes generation, discovery emphasizes recognition. The mind does not fabricate coherence from chaos. It learns to see the coherence that was already there. This does not diminish creativity. On the contrary, creativity lies in finding the right way to look, the right conceptual lens through which the structure becomes visible. If cognition resembles discovery more than computation, then attempts to model the mind purely as an algorithm will always fall short. They may simulate behavior, but they will miss understanding. Understanding involves insight into necessity, an appreciation of why things are as they are and could not be otherwise. This quality cannot be reduced to procedural execution. To think is not merely to calculate, it is to explore a landscape of meaning, to uncover relationships that are not invented by the explorer, but revealed through exploration. Cognition, at its deepest level, is an act of discovery, an encounter between a finite mind and an order that exceeds it, yet is somehow accessible to it all the same. The human mind occupies a peculiar position in the universe. It is undeniably grounded in physical processes. Neurons fire, chemicals flow, energy is consumed. Yet what the mind produces, meaning understanding truth, does not appear to be physical in the same sense. A thought cannot be weighed, a belief cannot be located in space, and an insight cannot be measured in volts. Still, these non-physical elements shape behavior, culture, and even our understanding of the cosmos. The mind seems to stand at a crossroads, connecting the tangible machinery of the body with domains that transcend it. This bridging role becomes clear when we consider how physical processes give rise to abstract understanding. The brain operates according to the laws of physics, yet it can apprehend those very laws. This reflexivity is extraordinary. The same universe that unfolds according to mathematical principles has produced systems capable of recognizing those principles.